Okay, so here we've got a question that shows a shaded region R bounded by the curve y equals 3 over the square root of 9 minus 2x squared. And you've got between y equals 1 and y equals 3. Find the equation of the vertical asymptotes of the curve, and then find the area of the region R. Well, to find the vertical asymptotes, you're really looking for domain restrictions. And the key thing is the denominator here can't equal 0. So you're really solving for 9 minus 2x squared equals 0. Okay. Because the square root of 0 is 0. That means 2x squared equals 9. X squared equals 9 over 2. So x equals plus or minus 3 over root. Those would be your equations of the asymptote. Now we might need a little bit more space for the next part, but it says to find the area of the region R. Okay, well, we'll use the diagram to give us an idea and then we'll do it. So we want to find a region. That's an area. So we have two options here, really. We can either do it as, we can think of it as either cutting it sort of horizontally, doing it as dx, or we can think of it as dy. Now, the thing is, right now, we just know it's between y equals 1 and y equals 3. And we have y equals the function. So you have two options. You can either do it as dx, but if we do it as dx, we need to then find this x value. So we know it's going to be the integral from 0 to a of y dx. So that's one way to do it. Or alternatively, which may not be easier, you could think of it as dy. Now, dy, you know it's going to be from integral from 1 to 3 because you're starting from 1 and you're going to 3. And then you need to have the integral of x dy. So that would actually cut it, the diagram is incorrect. That would actually cut this way using the sort of red dy. And dx would sort of cut it this way. All right. Now, because we have this function here, we may wish to want to integrate it that way, and otherwise we're going to have to solve for x. Theoretically, we do it both ways. So for demonstration purposes, let's do it both ways. One way may end up being nicer than the other. So let's consider it using dx. So firstly, we need to find when. So we're going to let y equals 3. That means, of course, 3 equals 3 over the square root of 9 minus 2x squared, which means square root of 9 minus 2x squared equals 1. So 9 minus 2x squared will still equal 1. So 2x squared must equal 8. X squared equals 4. So x equals plus or minus 2. Clearly, for what we're looking for our point on the right, x equals 2. Which means that our region area is going to be the integral from 0 to 2 of, well, 3 minus y, because it's the top, right? It's the top boundary over here. You want to slice it this way at the moment. So it's the top boundary, so that's y equal to 3, minus the bottom, which is y equals this 3 over the square root of 9 minus 2x squared. So that means it's that dx, which means it's the integral from 0 to 2 of 3 minus 3 over the square root of 9 minus 2x squared dx. Now, That's the integral from 0 to 2 of 3 dx minus 3 times the integral of 1 over the square root. Well, it's the square root of 9 minus 2x squared dx. But let's take out 2, which means you've got 9 over 2 minus x squared dx. That's 3 times x, right? 2, 0, minus 3 times the integral of, well, 3 over root 2, we can take out the root 2, 1 over, now it's 9 over 2, so it's really 3 over root 2 all squared minus x squared dx with a square root. So you've got the square root of a squared minus x squared dx. Now, that's going to be 6 there, minus 3 over root 2. Now, because a squared minus x squared dx is going to just be sine inverse of x over a. So x divided by 3 over root 2. So it's going to be times root 2 over 3 plus c. Of course, we need to then sub in our limits of 0 to 2. So it will be sine inverse of 2 root 2 over 3 minus 0, which is 0. And there is no plus c because it is a definite integral. Now, they didn't say if they want it in exact form or anything like that. So I guess that's the exact form. If you wanted it to a certain number of decimal places, then make sure your calculator is in radian mode. And then just quickly type that in the calculator. Giving you an answer of 3.39 u squared for 2 decimal places. So that's using dx. dy may not be nice. The reason why dy might not be nice is because we need to get x. So we could give that a go, but it probably will be a bit more difficult. So we've mentioned that the area of the region is going to be the integral from 1 to 3 of x dy. Now, the annoying thing with this is we now need to work out x in terms of y. That might be easier said than done. Like, we can work it out, but then it's a question of can we integrate it? So that means 2x squared is equal to 9 minus 9 over y squared. So x squared equals 9 over 2 minus 9 over 2y squared. So that means x must equal plus or minus 9 over 2 square root 1 minus 1 over y squared. So clearly, that's much more difficult to integrate in comparison because you've got the 1, so the square root of 1 minus 1 over y squared. So we won't do that, but theoretically, if you integrate this and you should get the same answer. So those are two different ways that you can think of to do the question. You could, of course, I mean, I don't think it's worthwhile here, but you could, of course, have also done it as the rectangle area minus this area and just work that out, sort of integrating there. But I don't think that's necessarily going to make things any easier. Just simply do top minus bottom, and integrating should be sufficient there.